This is RD Sharma solution, class 12, chapter 19, exercise is 19.5. We are taking indefinite integrals. So in this question, what we have done in the previous 5 questions, say similarly we'll do it here. We just have to see if this 3x can be made as 7x. It's not possible right now. Not easily possible. It's possible, but not easily possible. So the best way is to take 7x plus a 9 is equal to some t. This will be, when you differentiate both the sides, dt by dx, this will be 7x plus 9 differentiation, that will only give you 7. So whenever we have dx, we'll replace it by dt by 7. The second thing what we have to do is, because we need to replace x by t we have introduced by ourselves. For that, 3x plus 5, we will try to find out the t in terms of x. So this goes 9 here, t minus 9 and divided by 7. So this is x. X is equal to t minus 9 by 7. X is represented in terms of t. That we are going to replace in the original integral which is being given. So this is 3x plus 5. Let me write this t minus 9 by 7 directly here. We have a 5 also here, plus 5. In the denominator, it's under root 7x plus 9. So we have already chosen 7x plus 9 as t. And this is dt. And now remember, this dt will not be only dt by 7. So I'll just include that 7 in a bit. Now let me just resolve this what we have got, and then we'll go to that dx equals to dt by 7. So I'm just separating all of these. Every time integration and dt will be there. I'm not writing it, but just be sure that it will always be there. So 3 into t, it's divided by 7. And because under root t is in the denominator, it comes like that. Now 9 3 is 27 and divided by 7 under root t. Then we have 5 divided by under root t. And then we have all dt and integral always going on with each and every term. So if we take this 7 outside, it will be easier for us to deal, because 7 was already there outside, because dx was actually dt by 7, if you remember. So this 7 is going to be taken from the denominator. It will make the computation easier. It's not that it's not any trick. It's just that it will make your life easier. So this dt was actually dx was dt by 7. So 7 was already there in the denominator. I am suggesting you to take 7 from the denominator again. So once we take this 1 by 7 and 1 by 7, or this will make 1 by 49. 7 7s are 49. Okay, we are keeping it in a, say bag. We'll pull it out whenever we want. Now I'm integrating it 3, because constant always take outside integration, that it will be easier. Here 27 1 by root t, here's 35 by root t, 1 by root t. Now can you see some terms having similar formation, or they are called similar terms? Yes, 27, negative 27 and 35. So you can just subtract this 35 minus 27. And that will give you 8. So this 3 will remain like this, and 35 minus 27 I have written as 8. Now let us turn our eyes towards the integration. T by under root t. T is t only, t raised power 1. Under root t in the denominator is t raised half. And this goes up, it will become t raised minus half. When the bases are same, the exponents get added. So 1 minus half is half only. Now coming to the second term, which is 8 as the constant, we have 1 by root t. Root t is simply t raised half. It goes up, it will be t negative half. So now we add it. Means we'll just use the formula of x raised n, integration of x raised to the power n. So it will be t raised 3 by 2 by 3 by 2. Here 8. T raised minus half plus 1 is half only. 1 minus half is half only. So t raised half in the numerator and t raised and half in the denominator. So this is how you are going to go about it. So this is 8t to the power negative half plus 1, negative half plus 1 in the denominator as well. So this half. Remember 2 will go up, here 3 by 2 will go up. So 3 into 2 by 3, t raised power 3 by 2 plus 8. This is going to be t raised 1 minus half is half. 1 minus half is half. This goes 2 up. Okay, let us make it easier. 3 gets cancelled. We are taking 2 common, because you can see in both the terms 2 is common, and t raised 3 by 3, t raised half can also be taken common to make it easier. Please remember, the first term has 3 by 2, the second term has 1 by 2. So I am suggesting take 2 outside, and t raised to the power half should also be taken outside. So when you take this, 1 plus 1 by 2 is half. Remember? So when you take half out of this t 3 by 2 raised to the power 3 by 2, only t will remain. Similarly here, when you take 2 outside, it will be 8. It has become so easier now. Now t was initially 7x plus 9. Don't forget that. So this 1 by 49 was always already in the bag. So I am just pulling it out, keeping it in the denominator. Here we have 7x plus 9 to the power half, which is essentially equal to root 7x plus 9. And t plus, this is 7x plus 9, t plus 8. So do we have, so 8 plus 9, and 8 plus 9 is what? 7x plus 9 plus 8. So I'm writing it here. This is very basic thing. You can always do it. Just for the sake of completion, I have to do everything. So just bear with me. It will be 7x plus 9 under root. This 2 by 49 and 7x plus 9 to the power half already you got. And this is 7x plus 17 from here to here. And constant of integration is also very important. Don't forget that. So the approach was different, but this is also the way you can go about it. This is also the way you can solve. So the answer will remain same. If you see, the steps may be different, but the result remain the same. So this question is quite easier. It is very straightforward. You can go ahead if you want. But those who really want to know how to solve this type of questions, and this is simply x plus 4 in the denominator, we'll try to make x plus 4 or try to introduce x plus 4 in the numerator. So we have this x plus 4 minus 4 divided by under root x plus 4 dx. You don't have to replace this x plus 4 by some t or anything, because it's easier to make the numerator as denominator. Previously, because numerator denominator cannot be easily converted in the form, that's why we have taken it. Now here it's just x plus 4 minus 4. I've separated the term x plus 4 divided by under root x plus 4, and this is the second term is of course in front of you. It's minus 4 by under root x plus 4. So let us take as I1 and I2, integral 1 and integral 2. You don't have to take any t or something. First is x plus 4, the power is 1. Under root x plus 4 is what? See, under root x is simply x to the power half. Anything to the root is that power. So x plus 4 to the power half. When it goes up, it will be x plus 4 to the power minus half. So we have x plus 4 to the minus half, and this x plus 4 already remain. And since the bases are same, the power will remain getting added. So x plus 4 to the power 1 minus half is half 1. Now let us integrate this. It will be x plus 4 to the power half plus 1 divided by half plus 1. Half plus 1 is 3 by 2, and denominator 3 by 2, it goes up and it will become 2 by 3. Coming to the next part. So this 1 by under root x plus 4. X plus 4 to the power half only, it goes up x to the power 4 to the minus half. So it will be x plus 4 to the minus half, integration of x plus 4 to the minus half. It will be x to the power minus half plus 1 by minus half plus 1. Okay. This is I2. In the first term, it was negative, it was integration of x plus 4 to the power half. In the second term, it is x plus 4 to the power half. Negative half, half. There are two differences. So first term is 2 by 3, x plus 4 to the power 3 by 2. Second term, by mistake, I've written x. It has to be x plus 4. So this is x plus 4. Let me just change it. It is x plus 4. This is also x plus 4. So you have this 2. X plus 4 to the power half. Now this is, now you can take 2 common also, and x plus 4 to the power half also common, just to make simpler. Whatever you see common in the terms, you can take one of it common, or all the common terms, that is a common divisor, has to be taken common. So x plus 4 to the power half we have taken, 2 by 3 also common. When 2 by 3 is taken, so this 3 will be multiplied, because 2 by 3 has been taken out, that's 3 will be multiplied by the second term. So we have x plus 4 to the power half into 2 by 3, and since we have taken x plus 4 to the power half, only x plus 4 remain in the first term. The second term we have taken everything out, but because x plus 4 to the power half we have taken already, 2 already we have taken. So 4 was there, 3 we have to multiply, so it will be 12. X plus 4 minus 12. This becomes x plus 4 minus 12. X plus 4 minus 12 is simply x minus 8. So we are remain with the term x minus 8 here. X plus 4 to the power half was already in the front. 2 by 3 was also in front. So this is root because x plus anything to the power half is a root only. You know already that. So we have 2 by 3. Let me write it in a formal way. X plus 4, and this is x minus 8. This you can swap the terms. Position of the terms can be taken anyway. Plus c, constant of integration has to be taken. So please remember, integration and dx will always be there. I am omitting it, but you don't want to do it. So this was very straightforward question, and I suggested you can just go ahead and go with the next question. 2 minus 3x by under root 1 plus 3x. So if you have any way to convert 2 minus 3x easily into 1 plus 3x, it will be very easier. Alright, if it is not possible, then the simple way is to take 1 plus 3x as t. That's the standard way. Always remember, you don't need to press your brain hard. The best thing is take 1 plus 3x as t, differentiate both the sides. When you differentiate both the sides, you're going to get dt by dx equals to 3. So whenever we have dx, we will replace it by dt by 3. This is the first thing. The second thing is, since t is 1 plus 3x, we have to replace it by, x has to be replaced by t. So we have to have a relationship between x and t, which is given by this, x equals to t minus 1 by 3. And that's what we are going to place it in the original equation. So 2 minus 3 into t minus 1 by 3, 2 minus 3 into t minus 1 by 3, and divided by under root of t. And in place of dx, it's dt by 3. So this gets cancelled. You have 2 minus t minus 1. When you open it, it will be 2 minus t plus 1. That's the numerator has become very easy. 3 minus t divided by under root t. And this is dt. And if you want to take this 3, you can keep it there. But I would suggest you that just keep it away for some time. And then when you're solving it, you have to keep it there. You have to have it there, because examiner want to know that it is dt by 3. I'm just saying, because I'm showing it to you, explaining it to you. I don't want this 1 by 3 to be there. But you need to keep it, right? Okay, 1 by root t integration you already know, because root t is simply, when it goes up, it will be t negative half. This t by under root t to the power 1, under root t will be t half. It goes and it becomes t minus half. So 1 minus half is half only, so t to the power half. So 3 t to the power minus half plus 1 divided by minus half plus 1. See, these are its standard result. I'm just trying to explain this every time. But those who know, they can just skip or increase 1.2x speed. Now this is t raised half by half plus 1, 3 by 2, 2 by 3 goes up, t raised 3 by 2. So now we have, if you want to take common, you have 2 common, and t raised half you can take common. I'm just saying that in order to simplify these terms, you always need to take the common terms in both the terms. The common divisor, you can take it outside. 2 is already there. 1 by 3 is already there, because 1 by 3, this previously I told you it is dt by 3. So I'm taking, so this is, if you're taking 2 by 3 common, you have to have a multiplication of this. So all this is going on. This is simple calculation, right? You don't have to worry about all this, you know already about that. The main thing is 1 plus 3x has to be replaced by t, and dt by dx is 3. Replace x by t, x in terms of t. All these calculations which I am showing you, it's just the routine work for you. So now replace this t by 1 plus 3x. So this 9 minus 1 minus 1 plus 3x. And in place of this 1 minus 3x. So it becomes 8 minus 3x. So numerator will be 2 by 9 under root 1 plus 3x, 8 minus 3x plus c. It has become so easier now. So I'll show you another approach also just now. Answer will come same. So this is the way. The steps are more. I have taken less steps, but the concept remains same. The logic remains same. Okay, now here we have to deal with 2x minus 1 and 5x plus 3. We would like to get rid of the under root term. Try to replace it with 5x plus 3 in terms of t. So for that, don't worry. Whatever is inside your under root, just keep it as t. That is the trick. 2x minus 1 equals to t. Now differentiate it. When you differentiate it, you know dx can be written in terms of dt. So dx is dt by 2. And now this all x has to be replaced by t. So what is t? T will be from 2x minus 1. So x will be t plus 1 by 2. Whenever we encounter this, x you have to write t plus 1 by 2. So 5 into t plus 1 by 2 plus 3. This is the one term under root. So this is under root t only, because that's what the question is all about. That is the main logic. Under root t. 2x minus 1 can be taken as t, p, q. It's up to you. Normal ways to take t. Now multiply everything with whatever you see. So it is 5t by 2 plus 5 by 2 plus 3. So 5t by 2 plus 5 by 2 plus 3. And please remember, under root t is already there out. And this has to be multiplied by every term inside. So either you add 5 by 2 plus 3 first and then multiply it by under root t, or you can multiply first and then add, because that will be more, say, obvious. When you multiply this, 5 into t into under root t by t, 2 plus 5 by 2 into under root t plus 3 into under root t, because our root t is already there. I am not writing integration and dt. This is there, all right. Just for reducing the time for explanation, I am not writing integration and dt always, but it has to be there. Okay, 5 by 2 plus 3 is 5 plus 6 by 2, which is 11 by 2. So 5t root t, 5 by 2 and 11 by 2 here. These two integration has to be done in terms of dt. dt you need to replace it by yourself, because eventually t is introduced by you. So you need the replacement by yourself. So t into under root t will be t raised 1, t raised half, the power gets added, it's t 3 by 2. So you have to integrate t raised 3 by 2. So t raised 3 by 2 plus 1 divided by 3 by 2 plus 1 is the integration. So t raised 5 by 2 in the denominator. So 5 by 2 was already there, 2 by 5 comes in, and this is t raised 5 by 2. Coming to the next second term, 11 by 2. Under root t is simply, you know already, this many times you have done. Under root t is simply t raised half, so it will be t raised half plus 1 by half plus 1. So this will be t raised 3 by 2 divided by 3 by 2 in the denominator. Half plus 1 is 3 by 2. So it goes up, it will be 2 by 3. So you have t raised 5 by 2, the first term, and from here 2 gets cancelled, 11 by 3. Now you can take certain thing common. The best way is to take 3 common. So when you take 3 common, the first term will have 3 into t raised 5 by 2. The second term will be 11 into t raised power 3 by 2. And I was telling you that take something which is common to both the terms. So t raised 3 by 2 can be taken common. So when you take t raised 3 by 2 from t raised 5 by 2, only t will remain, because 3 by 2 plus 1 is 5 by 2. So you have to multiply these 3 as I suggested. This 3 was already been taken. You have 11, and this will be, because t 3 by 2 is already taken. So now we have come to a very safe point where you can replace it. Now this 3t, t is 2x minus 1. So you get 3 to the 6, 6 minus 3, 6x minus 3 plus 11, 6x, 11 minus 3 is 1 goes 8. So 6 plus 8, it's not minus 8. And 2 you can take common, it will be 3x minus 4 in this. So 2x minus 1 to the power, so it's 3 by 2 to the power, and this is, you can take 2 common, 2. So 3x plus x plus 4, 2 by 3. So this is your final result. And one more thing you need to understand, that whenever you integrate something, then you have to differentiate it and divide by 2. Alright? This has to be kept in mind whenever you integrate something, because 2x minus 1 has been taken somewhere. And as I told you that this dx was dt by 2, and I have not used that 2. So you'll see that in the result. See here, 1 by 2, and that 2 gets here. This is how the answer will come. So this is your whole result. You can just try it by yourself. The concept is, get rid of any term which is under root and try to solve it like that. So this question before integration needs some resolution or simplification. Under root x plus a minus under root x plus b, if it is in the denominator, multiply it by the rationalization factor. Under root x plus a is here, minus under root x plus b is here. Now just take the denominator, replace the mid sign by the opposite sign and multiply. So here we have multiplied the plus term in numerator and denominator both. Since we are introducing ourselves, that's why we have to do. And we know that a minus b into a plus b is a squared minus b square, and this is very helpful when we have under roots, values which are under roots, because square of our under root is the same term. So we just multiply this, x into under root x plus a plus x into under root b, or you can take x common for now. We'll just see why. X plus a is under root x plus a whole square minus under root x plus b whole square. This is a squared minus b squared. You can just take the under root and square it. So the under root and 2 will get cancelled. X plus a minus x minus b. So x plus a minus x minus b. This x gets cancelled. You have a minus b. A minus b. A minus b, you have to keep it while solving. I'm just not taking it right now because that will create some complication here, because this is just an explanation, alright? Come to the integration now. So this one integration I will do, and the other will come by itself. You'll just see. So x into under root x plus a, 1 by a minus b, I'll introduce later. It's already there. You have to put it every time. This is just an explanation. That's why I'm not writing it right now. So this is so easy now. If you are able to do x into under root x plus a, just integrate the first term. The second term will follow the analogy. Wherever a is there, replace it by b then. So this is I1, this is I2. I1 is x into under root x plus a. See, this is x plus a minus a. X can be written as x plus a minus a. Inside you have already under root x plus a. So no replacement, no putting as or equating it to t. So you can write this x plus a minus a as x plus a separately and a separately. Now multiply. So x plus a into under root x plus a minus a into under root x plus a. Next is the integration. So we have x plus a to the power 1 under root x plus a. So this is x plus a to the power half. So x plus a to the power 3 by 2. So when you integrate it, x plus a to the power 3 by 2, and this is going to be a x plus a to the power half. And you know the integration now. But whenever you integrate, please remember you have to differentiate and divide the constant term in the denominator. That is what I have been telling you since we started this discussion. So x plus a to the power 5 by 2 divided by 5 by 2, 5 by 2 goes up, it will be 2 by 5. So this is x plus a differentiation. As I was telling you, the differentiation is 1. So this 1 goes in the denominator. I am not writing it, but I am telling you that this has to be done. This has to be shown to the examiner that you know this. Anyways, x plus a is not giving you anything. It's just giving 1, but still you have to do it. Now coming to the second term, x plus a to the power half, it will be x to the power half plus 1 by half plus 1. That is x to the power, x plus a to the power 3 by 2. 3 by 2 in the denominator, it goes up, it will be 2 by 3. So this also goes 2 by 3. So 5 by 2 in the denominator and 3 by 2 in the denominator. Okay, this goes up 2 by 5. X plus a to the power 5 by 2 and minus this goes up a into 2 by 3. 2 by 3 a you can call it. X plus a to the power 3 by 2. Okay, so this is the whole term. But this is only one term. You have to do integration of x into under root x plus b also. But from this you very well know that if you replace a by b, the same result will come. I mean, if you replace a by b, under root x into under root x plus b will come. Okay, I'm writing the whole term now. You have to do it under root integration of x into under root x plus b separately. Please remember. So we have 1 by a minus b, which I took out of my bag and kept it here. The first term is 2 by 5 x plus a to the power 5 by 2 minus 2 by 3 a into x plus a to the power 3 by 2. The second term you have to do it by yourself. But you can see that it will come as same as x into under root x plus a because they are almost similar term. Only a is replaced by b. So just take this term, write it again, replace a with b, right? So this will be 2 by 5 x plus b to the power 5 by 2 minus 2 by 3 b x plus b to the power 3 by 2. So this whole is there, and don't forget to add a constant of integration. Many teachers, they deduct marks if you don't write this constant of integration. So whatever is being discussed is right in front of you, and this is how your answer should look like. So the whole trick is first rationalization. The second trick is x should be replaced by x plus a minus a, and this x should be replaced by x plus b minus b, and the analogy should be followed. Okay, this is your final result. Constant of integration, don't forget about that. So this is all about this exercise 19.5. We'll go to 19.6 in a short while. Till then, take care and thank you so much.